In this video, we're going to look at using our properties of exponents rules, and we're going to look at more complex problems here. And as we progress our way to the end, the problems are going to get more and more difficult. Let's look at the one here on the top left-hand corner. We have 2y to the 5th power times 4 times y. Now, when I do these, I normally start, if I can multiply any coefficients together, I'll do that first. So 2 times 4 makes 8. So I have 8y to the 5th times y. Now remember, just y really has an exponent of y to the 1 power. And our properties of exponent says that if you multiply like bases, you add the exponents together. So that'd be 8 to the 5 plus 1 power, or 8 times y to the 6th. Now, this next one here, we have negative 7 times x to the 4th power, all being squared. Now, if you have more than one thing inside of the exponent, or inside of parentheses raised to a power, and this is a single one term because there's no plus or minus signs, but I have a coefficient of negative 7. It is often helpful to think of this in terms of you're almost having to distribute the exponent to both things inside of there. So, for instance, I need to raise the negative 7 to the 2nd power, and I need to raise the x to the 4th to the 2nd power. Well, power to power says you times those exponents, so that gives me x to the 8th. Well, negative 7 to the 2nd power, negative 7 times negative 7 makes positive 49. So I get 49x to the 8th power. Next one here, we have 2 times x to the negative 2nd power. Our properties of exponents say that if you have a negative exponent, we can make it positive by moving it to the other side of a fraction. Well, we don't see a fraction here, but remember, we can make any number a fraction by putting it over top of a 1. So I would want to make that x to the negative 2nd power have a positive exponent. I'm going to move it to the denominator in this case. Now the 2 stays on top because the 2 really has an exponent of 1, so it does not move. I just move the x to the negative 2nd to the bottom, and when I do, its exponent becomes positive. All right, this one here, we have 12 into the 3rd over 3 into the 4th squared. Now, one of the first things that I could do is I have the coefficients 12 divided by 3. I can simplify that. That would make 4. So 4 on top. So I have 4 into the 3rd over. Now I have into the 4th being squared. Power to power we multiply. So it would be into the 8th power. Now we're dividing like bases. When you're dividing like bases, you subtract the exponents. Now we would do top minus bottom, but that's going to wind up with a negative exponent because we have more exponents on the bottom than we have on the top. So what we can do, since our goal is to have all positive exponents when we're done simplifying, is since we have more exponents of n in the denominator, we're going to still subtract, but we're going to do big minus little. So we're going to go 8 minus 3 makes 5. And we're going to keep the n's in the denominator because there's more of them down there. So it'd be n to the 5th power. So 4 over n to the 5th. All right, similar but different here. All right, we have 20t squared over 5t quantity squared. Well, let's start first by applying this squared to everything that's inside of it. And rewrite. So we do that. We have 20t squared over, I got to square the 5 makes 25, and then t raised to the 2nd power makes t squared. Well, let's go ahead and reduce the 20 over 25 and worry about the exponents last. So 20 over 25. Let's see. That 5 goes into 24 times. 5 goes into 25 5 times. So I got 4 over 5 t squared divided by t squared. Now, we have t squared divided by itself here. If anytime you divide something by itself, so that could be dividing 2 divided by 2 or x divided by x, it doesn't matter as long as we're not talking about 0 divided by 0, which you're not going to encounter in this class. What's going to happen is they're going to cancel each other out because anything divided by itself makes 1. So the t squareds are going to cancel out. because they're the exact same thing. And when I divide that makes 1, so I got 4 over 5. Now, let me talk about why that is for a little bit before we go on to the next one. If I had t to the second power over t to the second power, our properties of exponent says that when you divide like bases, you subtract those exponents. So t squared divided by t squared makes t to the 2 minus 2 power, which is t to the 0. T to the 0 is 1, so there's no more t's, just a 1 there. So that's why we can cancel them out, and we just end up with 4 over 5. Next problem here. All right, so we have a lot going on here in this one. I would start by working with those coefficients since there's no exponents to apply to them. So 10 divided by negative 2 is going to make, I have negative 5. So I have negative 5, j to the negative third power over, now I could do something here. I have j to the negative third raised again to the third power. So power to power times the exponent, so that makes j to the negative 9. Now, there's a couple of ways of doing this. I could go ahead and subtract my exponents, or a lot of people actually like to rewrite the problem so it has positive exponents. So I would take the j to the negative 9 and move it to the top, j to negative 3, move it to the bottom. So the j to the negative 9 goes up here, and the j to the negative third is going down there in the bottom, and I'm going to rewrite and then worry about the division part. So negative 5 stays where it's at, times j to the positive 9, because that came to the top, and j to the third came to the bottom. Now when you divide like bases, you subtract their exponents, big minus little. I have more exponents of j in the top, so the j's are going to stay up there, so it'll be 5j to the 6th. And then there are no more j's in the denominator, so there's really a 1 down there. Anything divided by 1 makes itself, so it'll be negative 5j to the 6th power. All right, now we're on this one. So we got a lot going on here in this problem. Now, the other times we've started with the coefficients and trying to do stuff with them, but I have a 3 divided by negative 2. There's not really anything I could do there. So what that means is we're going to jump into applying this exponent of negative 1 to everything. So I'm going to apply the negative 1 as an exponent to all the exponents on the inside. And remember, power to power we multiply, so 3q squared over be negative 2. We have, that'd make p to the negative third times q to the positive 5 power. Now I would take any negative exponents and make them positive by moving them to the other side of the fraction. The p to the negative third is going to come up here, and we're going to rewrite. So we'd have 3q squared over negative 2 times, or actually I need that p to the third, times q to the 5th power. Now I can do my division because I have a q squared on the top and a q to the 5th power on the bottom. Now remember, when you divide like bases, you're going to subtract their exponents. Well, since I have a bigger exponent in the denominator, I'm going to keep q in the denominator, and 5 minus 2 makes 3. There's our final answer. All right, new problem here, a little bit more involved. So there's nothing I can really simplify right here out of the gate because everything inside of parentheses here has that exponent of 3. So I cannot do 6 divided by negative 2 because I have the exponent of 3 that's got to get applied to the negative 2. So we'll start by applying that exponent to everything in that denominator and rewriting. Now I have to apply that exponent to everything. So that 3 has to also get applied to that negative 2, which means we have negative 2 being raised to the 3rd power. So negative 2 times negative 2 times negative 2 makes negative 8. And then we go to the next term. So it'd be h to the negative 4 times 3 power, so h to the negative 12. And then times u to the 3 times 3 power, which makes 9. Now, from here, we can proceed, and I would go ahead and simplify my coefficients before I did anything with my variables. So 6 on top, 8 on the bottom. I could reduce that to 3 over negative 4 and write everything else. All right, now take anything that has a negative exponent and move it to the other side. So I'm going to move the h to the negative 12 to the other side of the fraction, so it's going to go to the top. And when I do that, its exponent becomes positive. So I have 3h to the positive 12 times h to the positive 10 u to the 4th over negative 4u to the 9th. Now we start putting things together. I can put the h's together. When I multiply like bases, I add my exponents. So that's going to make 3h to the 22nd power over u to the 4th over negative 4u to the 9th. Now, last move left, we got a u on the top and a u on the bottom. So when you divide like bases, you subtract your exponent. So I have 3h to the 22nd over. We have more exponents of u in the denominator, so that's where they're going to stay. So 9 minus 4 makes 5. So u to the 5th in the denominator. Now we have the hardest kinds of problems that we have. These have a whole lot going on, and you just got to work your way through them very, very carefully as you go. And so let's see, I would take this, since this is so involved, and I'm going to apply that exponent negative 1 to everything I have in here. And I'm going to go rewrite. So I have 2, I'm going to write my top, 2x to the 3rd, y to the negative 1, z squared, over, now I have 2 to the negative 1 power, we have x to the negative 3, z to the positive 1, and we still have times 2yx squared z to the 4th. A lot of stuff going on here. Now, from here, what I would do is I would take anything that had a negative exponent, so those three things, and I'm going to move them to the other side of the fraction I'm going to rewrite. So anything that's got a negative exponent, I'm going to rewrite it such that it has a positive exponent. So I'd have 2x to the 3rd, that y to the 1 moved to the bottom, z squared, so that was the top. And now let's see, I had to move the 2x to the negative 1 to the top, so that gives me another 2. Move the x to the negative 3, gives me another x to the 3rd up there, over. We have z times 2 times y times x squared times z to the 4th. And we got to move that y to the negative 1 to the bottom so it has a positive exponent. Now we're here. Now that everything has positive exponents, clean up your numerator and denominators. So we have 2 times 2, which we can make 4. We have just z squared. And x to the 3rd times x to the 3rd makes x to the 6th power. So that's everything on the top. Do the same thing on the bottom. Well, we have a 2 and nothing else that we can multiply with that 2. So we're going to write the 2 again. Then we have z times z to the 4th. Add those exponents together. Make z to the 5th power. We have y times y, which makes y squared. And we have a x squared down there we can't put anything with. All right, now we're dealing with division. So we'll start with dividing the two whole numbers. So 4 divided by 2 makes 2, and that 2 goes on the top. All right, now we look, and we have z squared over z to the 5th power. Well, we have more z's in the denominator, so z is going to stay down there. Subtract the exponents. 5 minus 2 makes 3, so I got z to the 3rd. So I did my z to the 3rds. We have a y squared, but it's only in the bottom, so we just keep it there in the bottom. And last part, we have x to the 6th on the top and x to the 2nd power on the bottom. So that means we're doing the division rule. We're going to have more x's in the numerator, so x's stay in the numerator. 6 minus 2 makes 4. So there is our final answer. All right, one more of these hard ones here. So same rule applies. You want to start by applying any exponents in the numerator and denominator if you got stuff in parentheses. Then make all of your exponents positive. Then start putting things together. So we're going to take, since everything inside of parentheses has that exponent of 2 here, we're going to apply that exponent to everything. So we have 2 to the second power times x to the 6. Power to power we multiply. Y to the negative 2. Z to the 6th power. Over, we got x to the negative 1. Z to the 4th. X to the negative 2nd. Y to the negative 2nd. Z to the 4th power. All right, now anything that's got a negative exponent, we move it to the other side of the problem, so that way it has positive exponents. So we have 2 squared, x to the 6th, z to the 6th. And then I'm going to change the colors for all the stuff that I moved. I got z to the 4th, another z to the 4th, and then red will be everything that I had to move. So on the top, we had to make a x to the 1, a x to the 2nd, a y to the 2nd. Move those 3 things, make positive exponents. And then on the bottom, we put a y squared down there. Now, start putting things together. So when I multiply like bases, I add their exponents. So in the denominator, I'll have z to the 8th and y squared. My numerator, I have 2 squared. We have x to the 6th times x squared. So it'd be x to the 6th plus 1 plus 2 power. So that means we have x to the 9th. And there's no z's, so I to put with the z to the 6th. And I have a y squared up here. Now that I've multiplied all this like bases, now we do the division part. And we're looking, now notice how there's nothing else to do with the 2. Like there's no 2 in the denominator, and I'm not multiplying. So let's go ahead and square that 2 and call that 2 to the 2nd power 4 over. All right, now we're going to do our division part. So we're looking, all of my x's are right here at x to the 9th. There's nothing in the denominator, so I know I'm going to have an x to the 9th power up there on the top. Now we got to do the division with z to the 6th power divided by z to the 8th. Well, there's a bigger exponent in the bottom than there's the top, so z is going to stay in the bottom. 8 minus 6 makes 2, so I have z to the 2nd. Because when I divide like bases, subtract the exponents. Now we're looking, and we have y to the 2nd power divided by itself, y to the 2nd. We saw this a little earlier in this video. When you divide two things that are identical, they cancel out and make a 1. Well, because everything is timesing in my problem, I don't write a times 1 anywhere, and I have my final answer.